Number 1, which proportion can be used to find what number is 15% of 280? Okay, so this is where we use is over of equals percent over 100. Okay, so it says what number is. So we don't know what number is. So the is blank. So we're going to put our variable there. So x over 15%. Okay, so 15%. 15 goes up top. 100 always goes on bottom. Of 280. So of is our 280. Okay, so now we're going to look over through our answers and we'll see which one matches. So we're going to look at the 15 over 100 first. Okay, this is 85 over 100. Okay, that's wrong. This one says 15 over 100. This one says 15 over 100. This one says 15 over x. Okay, that's wrong. Okay, now let's look at the rest. X over 280. X over 280. 280 over x. Okay, our best choice is B. All right, next one. Which equation could help you find the answer to the question 20.25 is 112.5% of what number? Okay, we'll notice in this one that our answers are not written as proportions like up top here. So this is the one where we're going to want to use the formula is equals percent times of. Okay, so we'll notice that 20.25 is, so we'll have 20.25 is what percent? 112.5%. Okay, well, with percents, remember you always want to move the decimal point over 2 places to the left, so 1, 2. So our percent is going to be 1.125. So 1.125 times the of. Of what number? So we don't know. Okay, so let's look for the equation that matches that. Okay, so first one, 20.25 equals, this one says 112.5. Okay, that's not changing it to decimal, so we know that one's incorrect. Okay, B, 20.25, 1.125x. Okay, B looks good. Let's check that, make sure the others are not correct. 20.25, good. 0.125. Okay, that one's wrong. And D, x equals, okay, this one's just wrong altogether. Okay, so our best choice is B. So we have B, B. All right, a runner. Okay, I'm sorry, that was loud. Runner ran 25 miles last week and 15 miles this week. What is the percent of change? Okay, well, percent of change is your original minus your recent. And then you're going to go ahead and divide it by your original. So, okay, so your original is 25. So 25 minus your 15. And then you're going to divide that by the original. Okay, so 25 minus 15 is 10 over 25. Okay, use your good old handy-dandy calculator. You're going to get 0.4. Okay, you're going to change that to a decimal by moving it 2 places to the right. So 40%. And we are going from 25 down to 15, so that is a decrease. So D, negative 40, a decrease is your answer. Okay, number 4, Dr. Yurkovich predicted we would have 2 snow days last year, but we actually had 5. What was her percent error? Okay, for percent error, you go ahead and subtract your actual from your predicted, so 5 minus 2, and you put that over the actual. Okay, so 5 minus 2 is 3 over the actual 5. Put that in your calculator, and you're going to get 0.6. Okay, that's not a percent, that's a decimal. We want a percent, so we're going to move the decimal over 2 places, and we get 60% B. What's the interest formula? All right, well, that's our I equals PRT, where I is your interest. Okay, P is your principal. R is your rate, and that's shown as a percent. And T is your time, and that's in years. All right, number 6. Ms. Hay earned $20 in simple interest from after depositing $160 in a savings account for 5 years. What was her interest rate? Okay, so again, we're going to use I equals PRT. We know our interest is 20, so we're going to put 20 equals. Our principal we know is 160. Okay, our rate we don't know. That's what we're trying to solve, so we're going to put that as R. And our time we know is 5. Okay, so we're going to go ahead and use our calculator and multiply 160 times 5. When you do that, you go ahead and get 800 R equals our 20. Okay, you're going to go ahead. Want to get R, so you're going to divide both sides by 800. Okay, go ahead and use your calculator, and you're going to get R equals 0.025. Again, just like I said before, your rate you don't want as a decimal, you want it as a percent, so we need to move it over 1, 2. So your rate is 2.5%. So you would go ahead and write that out as a sentence, and it'd say Mrs. Hayes' interest is 2.5%. All right, number 7. Ms. Hall deposited $1,350 in a bank account and left it in there for 3 years, earning compound interest. How much money will she have in her account after those 3 years if her interest rate is 6 3/4%? All right, first thing I do is I change this fractional percent to a decimal, 6.75. Again, you could use your calculator, do 3 divided by 4 to get your 0.75. Okay. All right, so that's it as a percent. All right, so first one, again, we're going to use our I equals PRT. Okay, so we need to do this 3 times because we know that's 3 years. So our interest is going to be our principal, 1,350 times, okay, and move it over 2 times, 0.0675, then times the first year. Okay, you multiply that out, and you're going to get I equal to 91.125. Okay, so go ahead and add that together. Being that this is money, remember, we're going to go ahead and round to the hundredths place. So it'll be 1350 plus 91.12 is going to bump up to a 3. Okay, add these two together. When you do that, total for year 1 is going to be 1,441 and 13 cents. Okay, so there's year 1. Year 2. Okay, again, same formula, interest equals. Now we're going to go ahead and take this down here and put that as our new principal. Okay, again, same interest rate, so the 0.0675 again times the 1. Okay, go ahead and multiply that out, and you're going to get approximately 97.28. Okay, again, we're going to add this together. We're going to add our 1,441.13 plus our 97.28. Okay, so we'll add that together. Okay, and our total there for 2 is going to be $1,538.41. Okay, so that's after 2 years. Okay, now for number 3, this is how many years we've combined it for. I equals, now our $1,538 $38.41 times our same interest rate, 0.0675, times the 1 year. Okay, so you go ahead and you multiply that out, and you get your interest to equal about $103.84. Then I'm going to go ahead and take my $1,538.41 and add our interest to that. So $1,538.41 plus the $103.84, and that will give me my final answer, which is $1,642.25. Okay, that would be your final amount. Then you'd go ahead and write that as a sentence, and it would say something like, Miss Hall will have $1,642.25 after the 3 years. All right, number 8. If Karen scores 6 goals out of 15 attempts, what percent of her attempts result in a score? She'll work with either a percent proportion or a percent equation. All right, I'm going to go ahead and do the is over of, or part over whole, equals percent over 100. So she scores 6 goals. So the other part, remember, it's is over of or part over whole. Okay. So in this situation, the part is going to be 6 goals out of 15 attempts equals what percent? So we don't know what percent out of 100. Okay. So let's change our percent sign here to an X. Okay, so let's go ahead and do our cross multiplication. Our 15 times X equals 6 times 100. Okay, so 15 times X equals 600. Okay, we want to get X by itself, so we're going to divide both sides by 15. X equals, that's a lousy, oh, it got worse. X equals 600 divided by 15 is 40. So again, it's not just 40, that means 40%. All right. So again, you'd write that as a sentence. 40% of Karen's goals result in a score. Number 9. During a sports camp, athletes stretch for 12.5% of their 2-hour afternoon practice. How much time is spent stretching during the afternoon practice? She'll work with either a percent proportion or a percent equation. Okay. So for this one, I think the equation is going to be, so we want to know how much time is. So we don't know. So X is 12.5%. We need to change that to a decimal. We're going to move it 2 places. So it becomes 0.125. 125% times the 2 hours. All right, so go ahead, use your calculator, multiply that out, and you're going to get X equals 0.25. So 0.25 hours. So again, you'd go ahead and write that out. The athletes spend 0.25 hours, or if you wanted to calculate that in to minutes, that'd be 15 minutes, stretching during an afternoon practice. All right, next one. What is a good estimate for 11% of 734? Okay, show your mental math process. Okay, well this 11%, we're going to go ahead and say that's closest to 10%. Because with 10%, we know that we can easily find out what that is by just moving the decimal to the left 1 place. So we're going to do 10% of 734. Okay, so the decimal on 734 is right at the end, so I'm going to move it 1 place. So 10% of 734 is 73.4. Okay. All right, next one, number 11. What is a good estimate for 81% of 77? Okay, so one way we can do this. There's a lot of different ways. Let's say 80%. That's roughly, 81% is roughly 80% of 77. That's pretty darn close to 80. So let's do 80% of 80. Okay. So 80% of 80 is about, okay, so that's 4/5 of 80. Okay. So now we can do some mental math. We go ahead and kind of do a little check mark. You do 80 divided by 5. So 80 divided by 5 is 16. Multiply by 4. Times 4, and that is 64. Okay, so there you go. All right, number 12. About what percent of the bar is shaded? And explain your answer. Okay, for these, I always like to start off by cutting it in half and going from there. So I look at this and, okay, so I know that that's 50% on each side. I can go ahead and divide it again in half. Then I'm dividing it into quarters. Okay, yeah, that's really well done. And I notice that this one is right at about half of a half. So half of a half, or 1/4, is about 25%. So, and that's how I'd explain it. I'd say about half of 1/2 is 25% shaded, or that about 1/4 of the total bar is shaded. All right, number 13. Kyle saved up to buy a watch that had an original price of $195, but is advertised as 35% off. How much will Kyle pay for the watch after a sales tax rate of 8.75% is applied to the discount price? Okay, so we're going to have our $195, and we're going to multiply that times 0.35. This is going to tell us how much he saved. Okay, so we know when doing that our discount is $68.25. So that's the discount, okay? That's how much he's saving. So in order to find out how much he spent on that without tax, we do the $195 minus what we just found, the $68.25, and that's when we get our price without tax, our sales price of $126.75. Okay, that's our sales price. Oops, safe door. Okay, our sales price. Okay, so let's go ahead. Now we want to find out how much the tax is going to be, because unfortunately we do have to pay tax. So 126.75 times, okay, there's our percent, so we want to change it to a decimal, moving it 2 places. So 0.0875. All right, so go ahead and multiply that out. You're going to get $11.09. That's your tax, okay? All right, so now to get the final price, you're going to go ahead and add your sale price plus your tax, okay? So 126.75 plus 11.09, and I get, let's see, $137.84, and that is your total cost. So again, you would go ahead and write that in a sentence, and your sentence will just basically say Kyle will pay $137.84. All right, last problem. Number 14. A DVD that costs $12.99 is on sale for 10% off. What's the total price you pay for the DVD after a 9% sales tax rate is included? Okay, so we start off with our cost, $12.99. Okay. Again, we're going to go ahead and find out what that 10% is. So we make 10% into a decimal by moving it 2 places to the left, which is 0.10. Okay, so go ahead and do that, and I'm going to get 1.299. Okay, and that we're going to round up to 130. Okay, so that's our discount. Okay, so in order to find the sales price now, I go ahead and I do my $12.99 minus my 130. Okay, once I get that, I find my sales price, which is $11.69. That's my sale price. Okay. All right. So if I didn't have tax, that would be my price. But I do have tax, so I'm going to take my sale price, $11.69, multiply that again by the tax, 9%. Well, 9%. I'm going to go ahead and move my decimal over 1, 2. So 9% as a decimal is 0.09. Okay. So multiply that out, and I end up with 1.05. That's how much dollars I have in tax. Okay. So now to find the total costs, I'm going to go ahead and I'm going to add my sales price plus my tax. That'll give me my cost. So $11.69 plus my $1.05, and that will equal $12.74. $12.74 is what you will pay. So I'll write that as a sentence. Bada bing, bada boom.